Hi guys, recording the podcast solutions to online quiz 3 from unit 5P, which is gases. Question number 1. This question was a little tricky because they're asking for partial pressure and you're given mole values. So we're going to be using equation 2b that multiplies the mole fraction by the total pressure. However, the total pressure is not indicated explicitly. However, I do say standard temperature and pressure. So they're asking for the partial pressure due to nitrogen. Total pressure at standard temperature and pressure, which is STP, is 1 atmosphere. So the mole fraction is going to be equal to the total pressure. So that's going to be 4/5 in this case, or 0.8. Which of the following gases would be expected to have a rate of effusion that is 3 times smaller than H2? Well, there's a square root involved. So if it's 3 times smaller, it must be 9 times heavier. H2 is 2 grams per mole. 9 times 2 is 18. 18 grams per mole is H2O. Of these gaseous mixtures, which of the following lists the 3 gases in order of increasing average molecular speed? So you should have the lightest one last and the heaviest one first. So O2 is 32, CO2 is 44, and HE is 4. So we're going to go CO2, O2, HE. That's this choice. 4. An ideal gas fills a balloon at a temperature of 27 degrees Celsius and 1 atmosphere of pressure. By what factor will the volume of the balloon change if the gas in the balloon is heated to 127 degrees Celsius? So there's 2 things in this problem. A, common sense approach first, and B, converting to Kelvin. So let's use the common sense approach. We're using equation 3, the before and after equation. Everything is held constant in this case, except for volume and temperature. So we don't know what V1 is, and we don't know what V2 is. They want to know the factor that it increased. So it's going to be V2 over V1. Now, logically, the temperature increased. It went from 27 to 127. So the factor for which the volume should increase should be greater than 1. Should be a positive number, because according to Charles' law, or according to your stick, your pen, if you increase T, you increase V. T increased, V should increase. This shows V going down. This shows V going down. C, D, and E are the only 3 that show V going up. So those are the options so far. And by what factor? Well, it's going to end up being, if you rearrange this equation for V2 over V1, you're going to end up with 127 over 27. And that's the distractor here. But if you convert these to Kelvin, you're going to end up with 400 over 300, which will reduce to 4/3. All right, A. Which gas, if any, has a greater partial pressure? Okay. All have the same. Okay, they all have the same partial pressure. We know that because if there are equal moles, that means N is the same. And they are at the same temperature in a closed vessel. That means they have the same volume. All factors are the same. The partial pressure is the same. Which gas, if any, has a greater density? Okay, well, there are all the same number of moles, but O2 has a greater molar mass. Therefore, O2 has a greater density. Density is mass per volume. So if density is mass per volume, they all have the same volume, and there are the same number of moles, and O2 has a greater mass per mole, then O2 will have a greater density. Notice, they're not asking you to explain these, so I'm just listing them out. In C, which gas, if any, has a greater average kinetic energy? Kinetic energy is only related to temperature in chemistry. They all are at the same temperature, so they all have the same. D, which gas, if any, will show greater deviation from ideal behavior? Okay, so if we think about the sticky chart, the more sticky it is, the more it deviates from ideal behavior. The less sticky it is, the more ideal of a gas it is. O2 is nonpolar, H2O is polar with hydrogen bonding. So H2O is the answer there. And for E, which gas, if any, has the greater average molecular speed? Okay, speed at a constant temperature is related only to molar mass O2 is 32, H2 is 18, so it's H2O. Take care, guys. Apologize if I sound a little tired. It's Sunday evening, but look forward to seeing you tomorrow. Bye-bye.